Are you nervous about starting Cal 2? Don't worry, here are 5 key calculus problems that will boost your confidence and get you ready for the next step. The first problem we're going to be looking at is taking derivative of tan x or tangent of x. You recall that the tangent of x can be written as sine x divided by cos x. Okay, so that means that we want to take the derivative of sine x divided by cos x. Now, you recall something known as the quotient rule, which says that if you want to take the derivative of a function divided by function of x divided by another function of x, this is giving us g of x multiplied by the derivative of f of x minus f of x multiplied by the derivative of g of x divided by g of x all square. Another way of saying this is low di minus high d low all divided by low low. Alright. So what we need to do is to identify what is our f of x and what is our g of x. So here in this case, our f of x is sine x, and what is our g of x? Our g of x is cos x. So the next thing we want to do is to find the derivative of f of x, f prime of x. So f prime of x is, so if we take the derivative of sine x, we're going to have this to be cos x. And if you take the derivative of g of cos x or g of x, you're going to have negative sine x. Okay, so since we have this recipe, we can just substitute all this information back in our quotient rule. That means the derivative of sine x divided by cos x is simply g of x, which is cosine of x, multiplied by f prime of x, which is still cos x, minus, here we have f of x, which is sine x, then multiplied by g prime of x, which is negative of sine x. So we have this to be negative of sine x, all divided by low, which is just cos square of x. And if you multiply cos x multiplied by cos x, you're going to have this to be cos square x. Now what do you see here? You have negative. That means you have this to be positive. Then you have this to be sine square x, then divided by cos square x. And we can remember that sine square x plus cos square x is 1 from trig identity. Then here we have this to be cos square x. And what is 1 divided by cos x? 1 divided by cos x is simply secant x. So that means if you square this, that means you have this to be square also. So you have this to be secant square x. So I hope you're able to remember a few things on that taking derivative. Alright, so the most important thing you have to remember here is the quotient rule. How do you take the derivative when you have function divided by another function? You use quotient rule. Another one I would like to remind you of is the product rule, which says that if you want to take the derivative of product of two functions, you're going to have this to be f of x multiplied by derivative of g of x, then plus g of x multiplied by derivative of f of x. I want to encourage you to try this problem, and I want you to put your answer in the description box below. So I'll just help you a little bit here. Derivative here can still be written as sine x, can be written as 1 divided by cos x, and you can apply the quotient rule to do this problem. All you need to do is to identify your f of x and identify your g of x, then you can try this problem. So let's move on to the next problem. In this problem, we want to find the limit, or we want to take the limit of these two functions, that is x multiplied by ln of 1 plus 3 divided by x. Naturally, when you want to take the limit of a function, we directly substitute the value of x. Okay, here we have our x to be tending towards infinity, and by direct substitution, if you substitute x to be infinity, that means you have it here to be infinity. And here, when you substitute x to be infinity here, what do you observe? You observe that this is 0, right? Because 3 divided by, as x goes to infinity, 3 divided by something going to very large is 0. So here we have ln 1, which is just 0. So we have infinity times 0. However, you can always rewrite this as, of course, we want a situation whereby we can have indeterminate forms. Okay, so we have several indeterminate forms, just such as 0 divided by 0 or infinity divided by infinity, and so on and so forth. But however, we want to see how we can write this as 0 divided by 0 or infinity divided by infinity. We can simply write this as limit at which x goes to infinity of ln of 1 plus 3 divided by x, then divided by 1 divided by x. Now what do you observe? You observe that this is, in fact, if you do direct substitution, notice that this is going to 0, this is going to 0, and this is also going to 1 divided by infinity is also 0. So we have a case whereby we have 0 divided by 0, which is an indeterminate form. So here we can conveniently apply our L'Hopital's rule. And how do you apply your L'Hopital's rule? You apply your L'Hopital's rule when you have an indeterminate forms, such as 0 divided by 0, infinity divided by infinity, and so on and so forth. We can apply our L'Hopital's rule. So now that we apply our L'Hopital's rule, all we need to do is to take the derivative of the numerator and also take the derivative of the denominator. Okay, so let's take the derivative. If you want to take the derivative of ln of 1 plus 3 divided by x, so what is the derivative? So to take derivative, we need to take derivative of what it's inside first, okay, because we have function of a function, and that's chain rule. So remember chain rule, that if you want to take the derivative of f of g of x, this is g prime of x multiplied by f prime of g of x. Okay, so this simply means you're taking the derivative of this function with respect to your g of x. The convenient way to do this is to substitute let u be g of x. All right, so here we let u to be g of x, which is just 1 plus 3 divided by x, and if you take the derivative with respect to x, we're going to have this to be negative 3 divided by x squared. Okay, so here we have our, let's call this function y, so that means we have our y to be ln of u. All right, and what is the derivative of y with respect to u? Because here we want to take derivative of our f with respect to g of x, so that's why we are taking derivative of y with respect to u. We have this to be 1 over u. Okay, so that means that our dy dx, which is just negative 3 divided by x squared multiplied by 1 over u. So what is our u? Our u is 1 plus 3 divided by x. So we can simplify this to be negative 3 divided by x squared. So if you multiply x with 1, you're going to have x squared, and if you multiply 3 x squared by 3 over x, you're going to have this to be 3x. So again, we want to take the derivative of 1 over x. So the derivative of 1 over x, is simply negative 1 over x squared. So all we need to do is to substitute. That means we're going to have this to be the limit at which x goes to infinity of negative 3 divided by x squared plus 3x, then divided by negative 1 over x squared. So here we can sort of simplify this to be the limit at which x goes to infinity of negative 3 divided by x squared plus 3x, then multiplied by, because we are dividing, that means this is going to be multiplied by negative x squared. So that means we have this to be limits at which x goes to infinity of negative by negative, that's positive 3x squared divided by x squared plus 3x. So because we are taking a limit at which x goes to infinity, we can sort of factorize the highest power of x. So that means we have the limit at which x goes to infinity of x squared. Okay, so yeah, just factorize the highest power of x. Then here we have x squared, then 1 plus 3 over x. Okay, so because if I expand this, I'm going to have this result back. Like I'm just going to have this value here. All right, so x squared can cancel its x squared, and here we have this limit at which x goes to infinity of 3 divided by 1 plus 3 over x. And if you take the limit at which x goes to infinity of this, you're going to have this to be 0. That means we have this to be 3 divided by 1, which is 3. All right, so I hope you have learned something from this question. So as a recap, we try substituting the value of the limit. We had infinity times 0, so we wrote this problem as something that can give us an indeterminate form, which is 0 divided by 0 or infinity divided by infinity. So in this case, we had this to be 0 divided by 0 by writing x as 1 divided by 1 over x. Then when we had 0 divided by 0, we used the L'Hopital's rule by taking derivative of the numerator and the derivative of the denominator separately. And when we did that, we had this result over here. We had this result and this result over here. Okay, so and we simplify the expression here, then we had this result over here. After a few simplification, we had this result. Then here we can conveniently take the limit at which x goes to infinity, and we had this result. So I want to encourage you to try this problem. So taking the limit at which x goes to infinity of square root of x multiplied by e to the power of negative x over 2. So if you get the problem, I just want to encourage you to put your answer in the description box below. I'm sorry. I want you to put the answer in the comment section box below. So let's move on to the next problem. That is, we want to find the derivative of arctan of x. So first of all, the question is that how do we take the derivative of arctan of x? Now, most of the time when you want to take derivative of a function that you don't know, most likely you want to write it as a form of something you know, like something you can take the derivative of. For example, you can take the derivative of sine x, you know the derivative of cos x, and you know the derivative of tangent of x. However, we don't know how to take derivative of arctan of x, and that's what we want to do in this video. First of all, we have y to be equals to arctan of x. That means if I take the tangent of both sides, since arctan is just an inverse operation for tangent, that is, if I have my y to be f of x, the inverse operation of y is f inverse of f of x. That is, I'm moving a step forward, and the inverse operation is taking the step backward. So if I do that, I'm just going to be on the same spot. So if this is my x and I apply f, that is to go forward, I'll be at this point. And if I apply inverse of f, that is by going backward, I'll be on the same spot. So that's why this is x. Then I have this to be f inverse of y. And why is this important? You're going to see that as we progress. So let's take the tan of both sides. So if we take the tangents of both sides, we're going to have this to be tan of arctan of x. And from here, you can easily guess the result. What is tan of arctan of x? Arctan is an inverse operation. You take a step backward, and tan is a forward operation. That is, you're taking a step forward. That's like you're just going to be at the same spot x. I hope that makes sense. Then we have this to be tan of y. Recall that our goal is to take derivative of course, we replace this as y. We replace arctan of x as y. So we want to find the derivative of y with respect to x. So here we can do implicit differentiation. And what is the idea behind implicit differentiation? The idea behind implicit differentiation is embedded in chain rule. That is, if I want to take the derivative of function y, if I want to take derivative of y with respect to x, I can take the derivative of y of x with respect to y, then take the derivative of y with respect to x. Naturally, what you want to do here is that dy can cancel dy, and then you are left with dy dx. Okay, so that's the idea. That is, if you want to take the derivative of a function of y with respect to x, you take the derivative of that function of y with respect to y first, then you multiply by dy dx. So here we want to take derivative with respect to x of tan y, then here we want to take derivative of x. Okay, so what do you observe? You observe that this is a function of y. We want to take it with derivative of x. So that means that here I could have written this as function of y, which is a function of x. So this should be function of y with respect to y, then multiply by dy dx. Alright, because dy can cancel dy, then you're left with derivative of f of y with respect to x. Alright, so I hope that makes sense. So the idea is just that anytime you want to take the derivative of a function of y, just as in you have it as tan y, we need to take the derivative of tan y with respect to y first, then you multiply by dy dx. Then we can take the derivative of the right hand side, which is just 1. If you take the derivative of tan y, tangent of y, we're going to have this to be secant square y. Then you have this to be dy dx, then which is just equals to 1. And that means dy dx, which is what we are looking for, is 1 divided by secant square y, which is the same thing as cos square y. However, our answer is not in terms of y. We want to write our answer in terms of x. That is, we are taking derivative of y with respect to x. That means we want to have our answer in terms of x. And how do we do that? Alright, recall that tangent of y is x. That means if I should draw my right angle triangle, and I'd say this is y. Tangent of y is just the ratio of the opposites to the adjacent. That means we can write this as x divided by 1. And here we can use the Pythagoras theorem to calculate the third side. Of course, let's say this is our third side p. Pythagoras theorem says that 1 square plus x square is p square. And we're interested in p side p. That means p is just square root of 1 plus x square. So we can write this as square root of 1 plus x square. Alright. So since we are interested in finding cos y is just the ratio of cos of any angle is just the ratio of the adjacent to the hypotenuse. One of the ways I used to remember it is just sqrt. I know you must have remembered something like sqrt. So that's exactly what I'm using. So cos of an angle is just the ratio of the adjacent to the hypotenuse. So here in this case, the adjacent is 1 and the hypotenuse is square root of 1 plus x squared. And if I take the square both sides, that means I'm going to have this to be 1 divided by 1 plus x squared. And we're done. So the derivative of arctan of x is simply 1 divided by 1 plus x squared. Alright, so let's move on to integration. And before we move on to integration, I want you to try this problem. So try finding the derivative of arc cos of x. Okay, so we want to find the derivative of arc cos of x. So same idea, write it following this step. Write y as arc cos of x, take the cos of both sides, then you can follow through. Alright, so I want to encourage you to put the answer in the comment section box below. Alright, so the next problem we want to look at is integration by substitution. So here I forgot to put dx. Integration by substitution. So here, so basic idea behind integration by substitution is this: if you have the integral of a function multiplied by the derivative of that function dx, this is just simply if I let my u to be equals to g of x, right? That means du is simply, or du dx is simply g prime of x. So I just took the derivative of both sides with respect to x. So that means if I multiply both sides by dx, I can have this to be dx. So you can see that this is du and this is f of u. So this is the integral of f of u du. So how do I know I'm supposed to use integration by substitution? The basic answer is just that anytime you see the derivative of a function popping out from the integral. For example, if you take the derivative of x to the power of 3 plus 1, I'm sure that I'm going to have this to be 3x squared. So I have x squared, coming out somewhere. Of course, we can always multiply this by 3 and divide it by 3. It doesn't change anything. So the idea is that anytime you have the derivative of a function, function of a function like this, if you have the derivative of g of x, which in this case is just x to the power of 3 plus 1, popping outside. Here we have this to be 3x squared. That's when I know that I'm supposed to use integration by substitution. So let's try to use integration by substitution for this problem. So here we identify our u to be x to the power of 3 plus 1. And if I take the derivative of u, I'm going to have this to be 3x squared. Derivative of u with respect to x is just 3x squared. And if I multiply both sides by dx, we have this. We have 3x squared dx. And if I should make dx subject to formula, I'm going to have this to be du divided by 3x squared. So all I need to do is just to substitute this value here and this value here in my integral. That means the integral of x squared, square root of x to the power of 3 plus 1 dx, can be written as the integral of x squared, square root of u, right? Because our x cubed plus 1 is just u. Then multiplied by du divided by 3x squared. Of course, x squared cancels x squared. That means we have the integral of square root of u du. And what is the integral of square root of u? Of course, you can write square root of u as to the power of u du. Don't forget our 1 over 3 outside. That means we have 1 over 3 integral of u to the power of 1 over 3 plus 1 divided by 1 over 3 plus 1. So you just add 1 to the power. Provided that your power here is not -1, then you can always add 1, then divide it by everything here. So what I'm just using is that the integral of x to the power of n dx, provided that n is not -1, is x to the power of n plus 1 divided by n plus 1. That's if your n is not equals to -1. Because if you have -1, then you are going to have ln of u. Then here we have this to be 1 over 3. Okay, so then here we're going to have this to be 3 over 2. That's 2 over 3. Then u to the power of 3 over 2, which is 2, the same as 2 divided by 9. Then what's my u? My u is just x to the power of 3 plus 1 to the power of 3 over 2. Because this is an indefinite integral, we need to add our arbitrary constant c. So I hope you've been able to remember integration by substitution, so you can try this problem. So here also you are expected to use integration by substitution. And what is the proper substitution here? So here we let u to be -x squared. Well, how do I know that I'm supposed to use -x squared? Just take the derivative, because you see that this is a function of another function. That is, you have a function of x to be e to the power of u, let's take for example, and your u now is now negative x squared. So we have a function of a function. However, if I take the derivative of u with respect to x, I'm going to have this to be negative 2x, right? So you can see something here that we can always multiply this by negative 2, then divide it by negative 2. So, I can use integration by substitution. So I want you to try that. Okay, so then the last problem for the day is taking the integral of sine x to cos x, sine square x, and multiply by cos x dx. Here again, we want to use integration by substitution. Okay, so I want you to observe something, that if I take the derivative of, so let my u be equals to sine theta, right? If I take the derivative of u with respect to theta, that means I'm going to have this to be cos theta d theta. So that means that anytime you have a situation whereby you have sine theta multiplied by cos theta, and one of the power is even, okay, when I mean even means that you have powers of 2, and the other one is odd, you have powers of 1, 3, 5, and so on and so forth. So what you want to do is the one that has even function, you want to use that as your substitution. That is, we are making u to be sine theta, and if you take derivative of u, you're going to have this to be cos theta multiplied by t theta. That means that the integral of sine square theta cos theta d theta is simply the integral of u square then d theta. So we have cos theta d theta to be just be du, right? So this is just du, everything here is just du. Okay, so we have this to be the integral of u square du. Then if you take the integral of u square, you have u to the power of 3 divided by 3. Then we can add our arbitrary constant c. And what's my u? My u is just sine cube theta divided by 3, then plus c. So we're done. So the integral of this problem is just sine cube theta divided by 3 plus c. So if you have gained a lot from this question, I want you to try this problem. So here, you're going to let your u to be equals to cos theta. Then you can follow the same process. I want you to do it and put your answer in the comment section box below. I hope you find this video very useful. If you find this video very useful, make sure you click on the like button so that other people can get to see this video, and also click on the subscribe button just for you to be able to see more content from me. Thank you so much for watching. I hope you've learned a lot. Try to put your feedback in the comment section box below. Thank you. See you in the next video. Bye.